Okay, welcome back. So to close this, okay, this lab A, okay, using the VCS. To close this, you just type exit the DVE command line. Okay, and then it will ask you to confirm. Just type, you just click OK, and then it will exit you and bring you to the terminal window. Okay, and then from here, you can don't worry about the warning and so on. It's okay. Then you just type ls just to see what happened in your folder. So now your folder, you have more than one file. Okay, this is actually the file generated when you do the simulation, behavioral simulation. You can also clear the screen if I'm not mistaken. You just type clear. It will clear everything. Okay, and then you can ls again to see it more conveniently. Okay, we have those files, and you can also exploit using the folder. Okay, maybe you. Okay, this is actually the folder. Okay, under lab 0, and this is all the file, same as the file listed here. Okay, we have 1, 2, 3, 4, 5, 6, 7, and 8. You can count it and then same lah. Okay, all right. So now we move on to lab on VC. We finish VCS, Verilog Compiler Simulator, with the DVE. Okay, now we move on to the design compiler. So to do the design compiler, so remember the design compiler is actually to do the what we call the synthesis process. Okay, so we have finished this part A. Okay, to see the compiler, we go to part B. Okay, so under part B, we will be using the Synopsys design compiler, whereby our design multiplier, okay, our design multiplier will be synthesized using Synopsys design compiler or Synopsys DC. Okay, okay, we now at this stage. Okay, previously we at this stage RTL coding and simulation. Okay, so using design compiler. Okay, remember synthesis is actually the process of translating the RTL coding, okay, which is a higher level language to a lower level design abstraction. Okay, so to do the synthesis using design compiler, okay, you can create another folder. Okay, no problem. Okay, another folder, lab 1, for example, or any other name. This is just a suggestion, or you can even work under that particular folder, no problem. Okay, but always type this one when you want to use the software package. This is actually a white space lah. I'm sorry for this one, white space. Okay, you go back to this one. Okay, you see everything is in here. You can make a new directory like the mentioned by the lab. Okay, so let's say for directory work, source, db, and report. You can make it under lab 0. Okay, mkdir. Okay, work. Okay, so work. Okay, another folder. The next folder is src source code, your source. Okay, you just use the arrow up down button to speed up your typing process, and then db, actually this one, db, and then the last one, report. So this is optional. Okay, you can start straight away, or you create all the folder. Then you ls, you should be able to see all the folders here. Okay, db, src, work, and report. Okay, you can also move your copy your file multiplier here inside the source file. So during this stage, we're not interested to see the test bench. we are more interested to see our design file, which is multiplier.v. This is actually the same interface. You can copy here, okay, and then you can paste under source file. Okay, go back, and then if let's say you want to verify it, you can change directly to your src file, and then src folder, and then you add s. You should be able to see your multiplier. Okay, let's say you want to start from this directory. Okay, so remember, you need to source the type source Synopsys. Okay, I think if the computer memorize your step, then you can use the arrow up and down button. If not, then you need to retype it again. Okay, I think okay, now we have it. Okay, remember white space, here, white space. Then you enter. Now your computer is ready to call the DC design compiler DC. Okay, back to the step. What you need to do. Okay, we have created this. Okay, success, and then yeah, copy lab code to the source we did. Okay, part 3, starting the design compiler, analyzing and elaborating your design. Okay, so open a terminal and change directory to your any folder name. Depends on your lab folder. Okay, don't worry about this one. So start your design compiler. So in this case, we start it inside this folder. Okay, so we type pwd to know our location. So it's inside the source folder under the lab 0 folder. So what to type? You type design underscore vision. Okay, design underscore vision to call the software. Okay, right, design underscore vision, and then enter. It will bring you to the software design vision. Just wait for a while for the system to load. Okay, and then now this is the GUI for the design vision. So what to do? First, need to familiarize with the GUI. So this is the command line. Okay, instruction. You can also use the pull down menu here. Okay, so 2 ways to give instruction to the design vision software, either using this command, using this pull down menu, or using the command line. For the command line, you need to understand the command line first, and then we can also see the history of the operation of the process. Then this is the log file of the log operation. Okay, back to the that manual. Okay, when we open it, and then I think I zoom in. So we need to have library. Okay, remember in our ASIC design, okay, we need to have a library to infer the standard cell library to perform the logic synthesis. So we need to have a library, right? Library. So that library is actually already allocated for you. Okay, you can get it from the what we call directory inside the terminal. Okay, from the terminal. Okay, so to do it, you just follow the step. Okay, the step asks you to find these 3 library. Okay, sc max, sc underscore max db, to the same file. These two, we call it link library and target library. We use the same file, and then symbol library we use different file, sc.sdb. Okay, where to get it? Okay, you can zoom a bit this one. If you cannot see it clearly, I can demo it here. Okay, I think we take it from file setup. Yeah, we use option number 1 using the pull down menu, file setup. Okay, Okay, remember, if you see this, means that it's not yet ready. My advice, you delete all this. Delete, leave it like this one. Okay. So for example, you want to find the link library. So go find the link library. You click on this one. Okay. The wildcard is actually for, the system to search it through the directory. But the best, you can search manually. So find where is the file. Where is the name of the file again? sc underscore max db. Okay, for link library and also for target library. So where is it? Okay, we need to go to, okay, go to user if I'm not mistaken. So wait, I recall that computer EDA, yeah, EDA ref and then DB. Here is actually the location of the library. So I believe it's under DB. So sc max db. This is the file. Okay, then you open it. So you can see the path here. Okay, and then you click OK. So the path is from EDA ref db sc underscore max db, and then you OK, and then it should give you blue color like this one. Means that the working directory, sorry, the directory for the link library is okay. Okay, means that it's searchable by the system. Do it for the target library. Okay, remove this first. You can remove this first. Okay, okay, and then add, and then find sc max db, sc underscore max db. Again, same file, and then you okay, and then blue again. And then the last one, symbol library, you delete this one first, and then add again, and then find scsdb, as I'm not mistaken, you go back, yeah, sc.sdb. Then open, and then okay. All colors, blue colors, then means it's okay. Okay, don't touch this part, leave it. Okay, you can explore it after you finish your lab. Try to understand what's actually happening here, and then write inside your lab report. And variable also you can explore later on. Okay, and then you can write inside the report. Okay, this will give you extra marks to reflect your understanding. Don't forget to click apply. When you click apply and then OK button is inactivated, then it's okay, and then you can cancel. Now you have the file is assigned to you, library file. And then what's next? Okay, so click. So this we finish. Okay, okay, we also finish this. Okay, now we have all this. Okay, blue line, blue color. This actually, the next step is actually we load our Verilog code, the multiplier code just now. Okay, by using this command, file analyze. This is to load our Verilog code, the multiplier code. Okay, okay, file and analyze. Okay, so what to do? Okay, read the instruction. Click on the add button and click on the src subdirectory. So we adding our multiplier.v depending on your design. Okay, in this case multiplier.v. So click on the add button, then click on our multiplier. So see the location is under the lab 0 and src, and open. And then it is under library work and format. I think leave it as it is. Okay, add multiplier. To add the analyze command will do syntax checking. See, it will do syntax checking first and create intermediate.syn file. Okay, what is syn file? You can go online check under the Synopsys website to understand this. Then this will be helpful for you when you're writing the lab report. Why we need this file and so on. Okay, which will be stored in the directory work. Okay, that's why we leave it as work. Okay, and then define the define design library. Okay, so on. Okay. So we inspect the message in the log window. Okay, in the log window, and correct any syntax error if there's any lah, and do the analyze again if there is the error. Hopefully not error lah. But if error, then you learn new things. It's okay to have an error. Okay, it's good actually to learn from the error. Once you have successfully analyzed the code, select elaborate, and then we do elaborate after analyze. Okay, we do the analyze first, and then I think everything is okay. We use the library work auto. I think just put auto, and then okay. You see the log. Okay, now we do the analyze process. So this is actually the equivalent line of code if you want to do the analyze. Okay, we put it here using the command line. Okay, we try. Okay, you can copy this as your reference. Okay, when you write the report, that's actually the equivalent command line. Then we case here, for example, for your better access. Okay, so history, we have done the analysis. Okay, we have analyzed, and in the command here as well, we can see the process lah mentioned to you. Okay, all right. Okay, we open our design mission. Okay,